Hi, it's Madison Hendershott. This is my recreation of neurotransmission using candy. So I took shoelaces to make the presynaptic terminal. I'll write that. Put that right there. It's the presynaptic terminal. And then the next one is the postsynaptic. So there are neurotransmitters that are larger. They come in from the axon of the neuron into the presynaptic terminal. I'll use those as red. And then the ones that are synthesized in the presynaptic terminal, I'll use as orange. Put them right in here. These are Skittles. Okay. So these are just, the smaller ones are generally synthesized in the presynaptic terminal, and these red ones came in from the axon. So that was step one. It's just synthesis and storage of the neurotransmitters in the presynaptic terminal. And then stage two is neurotransmitter release. So once the neurotransmitters are synthesized, they need to be put into smaller groups to get ready for diffusion across the synaptic cleft, which is right here, this gap between the two, the presynaptic and the postsynaptic. So I'll use the Oreo cream as the vesicles where they're going to get grouped together. So I'll just put one there and one there. So then the neurotransmitters are packed into the vesicles. I'll just do 4. And then they're released into the synaptic cleft when they receive an order from the calcium ions to do so. The action potential is what opens this voltage sensitive gate. So I'll just do it like that. That'll be, doesn't want to stay. That's the little voltage sensitive gate. The calcium ions are able to rush into the presynaptic terminal once the action potential begins. So they rush in, and then that's what they come in from this area, the surrounding area, and then the calcium ions encounter these vesicles in the presynaptic terminal. As they enter and encounter the vesicles, the membranes of the vesicles then fuse with the membrane of the presynaptic terminal at this synaptic cleft. So I'll just put it like this. So that's them fusing together. And then the vesicles, as they fuse with the membrane, the neurotransmitters are then sent into the synaptic cleft. So I'll just put them like this. So they're in the synaptic cleft right now. So that was step 2. Step 3 is receptor site activation. That's when the neurotransmitters can diffuse through the synaptic cleft and be able to activate receptors on the postsynaptic membrane. So for my receptors, I'll use these Twizzlers. Okay. The membrane of the postsynaptic neuron contains a few channels. So these are the receptors that I just put down. And they have the ability to control how the neurotransmitter can be translated into an electrical signal. And that's step 3. So that's just them, And step 4 is neurotransmitter deactivation. So once the chemical neurotransmitter signal has been translated into the electrical signal in this process right here through the receptors, the synaptic receptors need to be cleared quickly. That's because there are so many new transmitters that need to enter and the process needs to happen quickly. So they don't back up and cause traffic, that kind of thing. The neurotransmitters can either be received by the postsynaptic terminal, so like absorbed, let's just say this is going through. They can either be absorbed like that, or degraded by a degradation enzyme. So I'll put that as it's a little corn chip. So basically it would go through here and then get broken up smaller. So I'll see if I can. That was my degradation enzyme. Or they can be received back into the presynaptic terminal. So it'll just use this as the little transporter back in, and it would just go back right in there. So there are 3 different ways that they can go back, and that's the end of neurotransmission.